Recording in progress.
Yeah. Okay, so today we're going to discuss about two things. One is the finals preparation, and number two would be about the sample server Naveen has posted yesterday. I just wanted to give a brief introduction to what that server has done, and then from there we'll move forward and continue with the discussion for finals. Right. Let me quickly share my screen and get it started. Yeah, is my screen visible? Yeah, okay. So many of the students have asked what to do for the final project because we asked you to create a front end. So one thing that we're expecting is just a simple HTML front end, which doesn't need to have like a fancy stuff and everything. All we're expecting is you have something that can take the input and give the output. So that's all we're expecting from you. In that lines, Naveen has yesterday shared a sample server for people whoever are facing some difficulties. So I'll just quickly go through what's happening in here. So primarily we have used two frameworks in this. We have used Node.js for the front end part, and we've used Flask and Flask course for the backend. So how so your app.js is basically your front end application. So essentially, as of now, it will take an input of any integer, and it will spit out and this input, whichever was given by the user, will be taken, and it will be sent to the backend for processing, and the backend will return a result in the form of it multiplied with pi. So that's what it is trying to do. So if you can see here, this is like a brief template of what you can do. So here we are saying like post the data. So whenever the user has input some data into the text box, that will be converted into a request format, and that JSON will be sent to the backend. So that's what happens here. And once you got the response from the server, that response will be displayed in this text box. So that is what's happening in this entire thing. So you can also do the similar thing. Instead of sending a single single request JSON, you can send the JSON with multiple key value pairs to the server, and from there you can do the processing. Now let's quickly take a look at the server, and then we'll move. So this is the sample server. It is also a very simple server. So we have a route called defined a route called multiply. So here from front end, whatever request that you have got from the front end, first we are printing this body, and once we have received this front end, we are just taking that message, and we are inputting that into and multiplying it with the pi value, and we are sending it as an answer to the out. And this is how a simple API route is created using Flask. Now you can use the similar method. So we are using post because we are exchanging the data. It's not just like a single side request, because the client is also posting data, and the server is also posting the data back. So this is how you can utilize. This is like a sample thing you can utilize to serve your models. Any questions on this? Okay, if no questions, I think we'll quickly move to the final review. So let's look at some questions. Uh, so we from midterm we have covered things like naive Bayes, unsupervised learning, k-means clustering. In unsupervised learning, we have k-means clustering. We also covered support vector machines and decision trees, right? So this study guide for finals consists of all those questions. So we will go through some of the sample questions that will be very helpful for you for the finals. One thing that I would like to tell all of you guys is this final is not, I don't, I've seen the paper, it's not as difficult as the midterm. So don't worry about that a lot. Ensure that you go through all the material clearly. I think then you will be able to solve it. You'll be able to do pretty well. Now, so let's go through some questions. The first question is, if a formula for naive Bayes is given by P class of data and P data of class data given class and P of class. So this is basically a Bayes expansion of P of A given B. Which of the following components makes it an algorithm naive? So I think this is like a straightforward question. So this is something called so this is called a posterior probability, P of class given data, and P of data is your P of class is your prior probability, and P of data is your instance probability, right? And I think P of data given class is your likelihood. So P of data given class is where you actually do the naive Bayes assumption and expand it such a way that if at all your data has like multiple features like x1, x2, x3, and so on, you assume that all of them are independent, so that because a joint distribution P of x1, x2, x3, and so on up to xn can be given by P of x1 given c1 into P of x2 given c2. So this particular thing is where what makes P of data given class is what makes the whole algorithm a naive algorithm, right? Naive Bayes assumption. So naive Bayes assumes that the input features are independent. We're just discussing about this. Yes, it assumes that all the input features are independent. For a continuous data, which formulation of naive Bayes are appropriate? So there are three different ways of naive Bayes, I guess, which you can apply. For discrete or categorical variables, you could use multinomial naive Bayes. I think that's what has been used mostly for your problem sets. And if at all you wanted to do naive Bayes for continuous data, you can use Gaussian naive Bayes. The only thing that actually changes with these things is the function that you use for each of these things. I think we have slides also for this. I can quickly go through and tell you about that. Yeah, here. Yeah. So for continuous data, we use Gaussian NB. For categorical data with order information, we use categorical NB. And categorical data with, this is without order information. This is with order information. And then we use multinomial NB anyways. And for binary data, we use Bernoulli naive Bayes. So this is a simple thing that if you look at these functions, each of the naive Bayes classifiers, you'll be able to understand why we use these particular classifiers for classification purpose. Now, coming to the next question, use the following data for remaining naive Bayes questions. Okay, so here in this question, we have 5 documents which are given. So it is like a text document that we have. And each of these document is classified into spam or ham, right? So if at all, so like document 1 and 2 are spam and document 3, 4, 5 are hams. And each document consists of some tokens, some text tokens. So this is like a text ordered this thing. So we'll use multinomial NB in this scenario. And document 2 has tax, so actually vacation, price, and document 3 has free puppy vacation, and document 4 has vacation, tag, ticket, tax, and document 5 has price, tax, and puppy, right? So now first question we are asking here is calculate the class priors for spam or ham. So I already told you prior is basically the probability of occurrence of the class, right? In all of these 5 samples that we have, 2 of them are spam and the rest 3 are 5. So probability of spam is 2 given 5, and probability of ham is 3 by 5, right? Now, next is to calculate likelihood for each word. So what is likelihood? Likelihood is nothing but probability of data given that particular class. So probability of price given that it is a spam. So given that it is a spam, we have a total of 6 tokens: price, ticket, free, tax, vacation, and price. There are total 6. Out of these 6, we have two times price is repeating, right? So probability of price given spam is 2 given 6. Similarly, probability of ticket given spam is 1 given 6, because in all the 6 variables that it has, the ticket has occurred only once. So the likelihood is likelihood of ticket is 1. Likelihood of ticket given that it is spam is 1. 1 by 6, sorry. Similarly, you can calculate all other likelihood for each and every words. Now, using naive Bayes, infer whether document 4 should belong to spam or ham. So now for this, we'll use slides that is better explained in that. With naive Bayes, we have to infer whether document 4 will belong to spam or ham, right? Okay, so before solving that question, I just wanted to give a small this thing for you while calculating this likelihoods. Sometimes it is possible that you'll get 0 probabilities. But the problem with getting 0 probabilities, whenever you get 0 probabilities, the whole probability of that entire equation will go to 0. Since we don't want that, what we do is we do something called smoothing. What happens in smoothing is, for example, there is an example for this in the coming questions, but essentially what we will do is we'll just add a parameter called alpha and alpha m to your class probabilities, essentially making your probabilities not equals to 0. That's what we will do using this this thing. Now coming to the question number 4, to compute using naive Bayes, infer whether document 4 should belong to spam or ham, right? So essentially, for you to see whether a particular document 4 belongs to spam or ham, first you need to calculate the probability of spam given that it is document 4, and similarly probability of ham given that it is given that it is document 4. So you need to calculate these problems. So think of this as probability of class C1 given that it is an X4, probability of C1 given X4, probability of C0 given X4. So we are trying to calculate those probabilities. Now, using the naive Bayes assumption, we generally in here, for example, we have instance probability, like probability of the instance prior probability. We generally ignore this instance prior probability while taking naive Bayes assumption. Now, assuming that particular thing is what we follow. So here, probability of class given instance. So think of it as like probability of spam given the instance is a document 4. We are trying to calculate the posterior probability of spam. And how do we calculate it? Probability of D4 given the class spam into probability of spam. So how do you calculate probability of D4 given class spam? So in D4, if you see in the question, in D4, we have vacation, ticket, and tax. We have three different things. So using the naive Bayes as independence assumption, we can split this vacation, ticket, and tax as independent variables, and we can compute it as probability of vacation given spam into probability of ticket given spam into probability of tax given spam. And finally, you're multiplying it with probability of spam, right? Now, similarly, you also, now we have already computed what are the likelihoods for each words. So all you have to do is let's multiply with all of them together and you will get the value. So it is 0.00185. Now, one more thing is probability of ham given document. In the same way, whatever you have done earlier, you will do the same thing here. And you got the value 0.00329. So by looking at it itself, you can clearly figure out that, the probability of probability of getting ham given a document 4 is higher than probability of spam given document 4, right? So one thing you have to do before this is a straightforward answer. But the answer is like ham. But one thing that you can do to get like more accurate value is you can apply a log to this particular thing, so that it will bring it closer to the comparable values. Then you can say in a proper manner whether it belongs to ham or spam. In here it is spam because this value, the value of ham is greater than the value of spam, right? Now, in the above problem, how would smoothing change the probability that document 5 is spam? So now next question that was how will you classify document 5, right? So if we take the document 5, we have price, tax, and puppy, right? Now I can just use the thing that we have here. Yeah. Now probability of spam given it is doc 5 is a probability of price into given spam, probability of tax given spam, and probability of puppy given spam into probability of spam, right? And if you we already have these likelihood values that we have computed earlier, and if we plug it in, we are getting it as 0 because probability of puppy given spam is 0. Why? We don't have any puppy in the spam category, so probability of puppy given spam will be equals to 0. So now, like, this is not a very accurate description of how this thing happens. So what we do is we convert this into a different thing. So basically, this what we have is 0 by 6. Now we just add, if at all alpha equals to 1, we are adding alpha 1 plus 1 by that value 6. Right, 6 is the total number of instances that we have in that particular category, right? In the spam category, we have total number of instances, that m value is equals to 6. So we'll have that as 6. So total value, you will get it as 1 by 12. So finally the probability of spam given doc 5 can be calculated as in this manner, like 2 plus 1 by 6 plus 6, 1 plus 1 by 6 plus 6, and 0 plus 1 by 6 plus 6 into 2 by 5. That equals to, this is 2 by 5 is your prior probability of that particular class. And compared to the previous 0 value that you got, now you are getting an actual 0.0013, which is non-zero. Which is very good that we are not smoothing the whole thing. So that is the thing about smoothing. Now the next thing, so obviously what how would smoothing change the probability that document 5 is a spam. So previously, without smoothing, the probability is 0. Now the probability has increased to 0.0013. So that means it has smoothing has increased the probability from 0 to 0.0013. So that's what's happening here. Now, next question, assuming that spam is a positive class, and what is the precision of classifier that predicted the following classes for documents 1 to 5? So what he has given is in the question, he has given some random labels for each of the document. Now we already have the original labels for each of the documents, spam, spam, ham, ham, and all. And we also have the predicted labels like spam, ham, spam, spam, ham. So if you construct a table like ground truth and the prediction table, from this we can create something called the confusion matrix. Confusion matrix are nothing but like this is the ground truth on your column side, and in your row side, and prediction on your column side. And if at all, because we are assuming the positive value is spam, now both of them are spam. Like so, the ground truth is spam and prediction is also spam. There is only one combination in this format. So the total number of true positive values are 1. And if at all it is ham and spam, we have ham and spam as 2. So we have 2 false positives. And in similar way, you can fill out this entire confusion matrix table. Now, once you have filled out this confusion matrix table, then you can figure out what's the precision, recall, and F1 score. These are pretty standard formulas. I don't think you have to by heart them or something. It is these things will be given in the cheat sheet. But precision is like true positives by true positive plus false positive. So if you take this table, true positives, the total number of true positives in this data set is 1, and total number of true positives is like 1 plus the total number of false positives are 2. So total value is 0.33. Similarly, you do it for recall and F1 score. And yeah, so this is what is the F1 score for the same set of predictions. So this all I think all 3 values are calculated. You have some value 0.4. Now, before moving to support vector machines, I'll pause for a second and ask if you have any questions in the naive base. Okay, I will move on to support vector machines. Now, in the support vector machines, according to the lecture material, which of these is a typical loss function used for SVMs? So SVMs is like this hard margin classifiers. I think this must have been covered in the class. We usually use something called hinge loss. All mean squared errors, Gini coefficients, and cross entropy, these are used for some other purposes. For support vector machines, hinge loss is majorly used. Now, SVMs are less effective when the data is linearly separable, data is clean and ready to use. Yeah, whenever the data is noisy and contains overlapping points. So this is kind of true for almost many of the classifiers. If at all the data is noisy and contains overlapping points, like SVMs are very less effective. In SVM, what is the meaning of hard margin? Again, these are all theoretical questions. If you just go through the lecture slides once again, I think you all will be able to understand these things very well, clearly. So in hard margin, there's nothing but the SVM allows very low error in classification. That's what hard margin means. SVM uses kernel tick to classify nonlinear data. Yes, it does use nonlinear. It does use kernel trick to reduce the dimensionality and to classify the nonlinear data. I don't know, grid search can be used to optimize hyperparameters of machine learning algorithm. True. Yeah, so we have already discussed this in one of our discussions. We have random search and grid search. These are the 2 things that we've used for finding optimal hyperparameters for our particular algorithms. What does the kernel function do? We just discussed this, transforms linearly separable data into separable data by transforming it into higher dimensions. Now the decision boundary is in nonlinear SVM must be linear. Yes. So this is also like a very theoretical question. If you go through the slides, I think you'll be able to understand why the decision boundary in a nonlinear SVM will be linear. When fitting on an SVM, we attempt to optimize. Uh, yeah, this is also the same thing, like the margin between the decision boundary and the data. So if you have like a line that is separating the positive values and negative values, you just try to find out the distance of this from each of the points, and then you kind of try to optimize it. So that's what happens uh, in SVMs. Okay. Now, yeah. So before yeah, moving to decision trees, any questions, anyone? Oh, 1 second. Okay. Yeah. Sorry about that. Okay. If we don't have any questions, then we can move on to the next thing: decision trees. Given the following decision trees, grown from the same data set, which is the most likely to be overfit? So yeah, so from here you can kind of think that like, so here I think the answer is pretty much sums up everything. If at all the leaf count is more, that means it's like more it can create more complicated decision boundaries. That meaning you having like more complicated decision boundaries means you're trying to fit the data in a you're trying to overfit the data. Like for every small condition, you have one leaf count. So you should not do that. That's basically overfitting. So I think for solving this problem, we use pruning in decision trees. Yeah, I think that's the next question. Why is pruning in the decision tree is required? To avoid overfitting and make the model more generalized, to eliminate unnecessary structures. Yeah, so that's kind of why we do it. What does entropy zero of an attribute in the data set mean? So if at all an entropy is zero, that means it has a very it has no randomness in its entire attribute. That means that data is homogeneous across this attribute. Information gain measures the increase in uncertainty obtained by splitting the data set on a particular attribute. It's false. Information gain, you can think of it as it is used to decide how to split the decision trees any further. I think we'll see an example of this, but it's not because of the uncertainty. Now, bagging of a decision tree involves generating the different decision trees, bootstrapping, and taking advantage of it. Those are all theoretical questions. I think you guys will be able to do it pretty well. Using information gain, determine which of the following splits is the most optimal one. Okay. So, okay, I think we must have, yeah. So in information theory, the formula for information gain is entropy of parent minus weighted average of entropy of children. If at all there are no weights given, you can assume that all weights are kind of equal or equals to 1 or something. And then from this, we are calculating the information gain. So like from 0.9 minus 0.1, I think these are the values that were given here: 0.9 minus 0.1 plus 0.7 by 2, because it's like averaged between these two children. And from there, you get these information values. And because 0.5 is the highest, because then you will have the highest information gain. So you will decide to do this particular split. Okay. What is the impact of not scaling features prior to fitting decision trees? Poor classification performance. So the impact is basically weight explosion. It's not any of these things. So these things will occur. It doesn't matter if you scale the features or not. Things will happen depend upon how you choose your model parameters. Now we'll move on to unsupervised learning. Before moving, does anyone have any questions? Okay, then I will move forward. Now calculate the centroid of the cluster with the following data points. So it's a pretty straightforward question. Just divide the sum of xi values and yi values and divide it with the total number of data samples. You'll get the centroid. I think that's what here happened. 17 by 14, 14 stands. Under what conditions can we say a K-means clustering model has converged? So here also is a theoretical question. When the intercluster distance is less than a threshold, when the number of iterations has reached a certain value, and when the wall time has been reached. All of these conditions can be used as a condition for convergence in K-means. Now, exclusive clustering stipulates that each data point can exist only in one cluster, true or false. Yes, it is true. Exclusive clustering means that. K-means clustering is robust against outliers. No machine learning model is actually robust against outliers, honestly speaking. But and the K-means also falls in the same category. What is the relationship between the distance between the clusters and corresponding class discriminability? It's proportional. Yeah. So think of it like the farther the point is from the cluster, it is easier for us to discriminate whether that particular. So we can just say if the distance is high from the centroid, that point doesn't belong to this. So it's like kind of proportional with class discriminability. If we had a dog in a picture data set and had unknown number of dog breeds deposited, which of this following is not a good use for K-means clustering? Discriminating between different breeds is kind of like a classification thing that you can do, but not for clustering, because it's not a discriminative approach. It's just like more of like a generative kind of an approach where you kind of get the similarities between the dog breeds and all. Okay. Assume the two centroids have location. Oh, this is also a pretty easy question. Essentially, what you're trying to do is trying to figure out what's the distance between the centroids which were given and each of the data points. And next question is like cluster assignment. This is also, as I said before, for cluster assignment. So we have already got the distances from each of these centroids to respective points. From these respective things, because you can see that D1, sorry, U1 to D2, take the centroids. What is the question? Determine the cluster assignments for each point. Yeah, so here, yeah. So D1, we can straightforward say, because it's mu1 is the centroid, we can straightforward say it is the value is, with the distance is 0, it belongs to cluster 1. And for D2, we are saying it is cluster 2. because here you can see the distance between the centroid mu2 and d2 is 0, but whereas mu2 and d1 is root 13. So we can kind of say that it belongs to cluster 2. So in similar manner, you can figure out for all other clusters, like with which cluster it belongs to, and then you just update the centroid using this d1 plus d4 by 2 formula. It's like similarly what we've done before. Yeah, so there's one, and there's one more important, so here distance metric is Euclidean distance. That is, it is possible also sometimes we might ask you with a different distance metric called cosine similarity. For example, let's say there are 2 points, A equals to 3205 and B equals to 1010. Let's say these are the 2 points that are given. And you're asking what's the cosine similarity between these 2 points. It's basically the dot product of this and divided by the norm of each of the point. So it's like for these 2 points, if you wanted to calculate the cosine similarity, it is 3 plus, because 3 into 1 plus 2 into 0 plus 0 into 1 plus 5 into 0. So basically it's 3 by square root of 3 square 9 plus 4 plus 25 and 1 square plus 1 plus 1. So overall the value of cosine similarity is 0.344. And the cosine distance is 1 minus cosine similarity. And uh, the cosine distance is this like 1 minus this value. And if at all there is a distance based clustering is happening, and like an agglomerator clustering and stuff, A and B won't be in the same cluster. This, let's say these data points A and B will not be in the same cluster, because we've decided the distance threshold is 0.5, but since the distance threshold is 0.659, sorry, 0.656, that means the whole value is not, they don't belong to the same cluster. Now, finally, coming to the dimensionality reduction part. So, yeah, I think all of these are basically some theoretical questions. So I'll just quickly go through them. Principal component analysis, like min-max optimization, is a pre-process. It's not a pre-processing step. We've already spoke about it. It's a dimensionality reduction technique which is used. So it just falls. So principal component analysis can be used to reduce the dimensionality from 100 features down to a single feature. Yes, that's true. Which of the following techniques would perform better for reducing the dimensions of a data set? Yeah, so removing columns with too many missing values would be more beneficial always than the other things in here. Dimensionality reduction algorithms are one of the possible ways to reduce the computation time required to build the model. Obviously, that's the whole reason point of PCA. In PCA, the largest eigenvector values, eigenvector gives the direction of the maximum scatter of data. Minimum scatter of data. No such information can be interpreted. Second largest. Yeah. So I think this thing might have been already explained in the class. Like, so eigenvectors are kind of like the basis for that particular data set. But yeah, so think of this as like maximum scatter of data is like what is given by the eigenvectors of that particular thing. And again, one more theoretical question. PCA is unsupervised method. It searches for direction. So I think 1, 2, and 4 are correct. All principal components are orthogonal to each other. Which of the following statement is correct for TNSE and PCA? Yeah, TSNE is like for non-linear, or PCA is linear. Has a closed form solution. True. Yeah. Yeah, so most of them are theoretical. Some of them are, these things. But yeah, most of your questions for your final also are going to be something very similar. So don't worry much about them. It will be easy only. So that's it, class, for today. If you guys have any questions, I will answer them. And once again, all the best for your finals. Yeah, I'll take some questions if you have any. Okay. you guys don't have any questions, all the best. Have a good day. Thank you for taking this course. I hope you guys have learned something. Uh, and one thing that I want you guys to take away from this course is uh, both the theoretical aspects of machine learning and how can you apply machine learning to some solving some real world problems. Uh, I hope we've done a decent job for this particular thing, but there is a lot more to learn. So keep exploring. Uh, they have like a humongous set of applications in natural language processing, computer vision, and lot more things, robotics. So keep exploring as much as possible. All the best, guys. Have a good day. See you.